Hi Diksha Didi, good evening.
Hi, good evening.
So today let's continue with our increment operators and unary operators where we left. So we are going to revise a bit before, like we're going to start from the unary operators chapter only, as we are having this class after a gap.
Okay.
So let's just start with unary operators in C++. So unary operators are the operators that perform operations on a single operand to produce a new value. So there are types of unary operators over here. We have unary minus, then we have increment plus plus, decrement minus minus, not symbol, address of operator and size of, right? So we are going to see all of these operators one by one. First is the unary minus. So the minus operator changes the sign of its arguments. So the minus operator can work as a unary operator, right? Or it can also work as a binary operator. Binary operators are those operators and the arithmetic operators that work with two operands. So the minus operator can either work with as a unary operator, or it can either work as a arithmetic operator, binary operator. So the minus operator over here in unary operators is used to change the sign of its argument, and there's only one argument in unary operators. So a positive number becomes negative and a negative number becomes positive. So like if we have a equals to 10, b equals to minus a, so it will just over here a's value is positive, so it will convert it into negative, so we'll get minus 10, and that will be the value of b. If we had minus 10 as a's value, then it will convert like from negative to positive. So from minus 10 it will be 10, and that will be the value of b. So unary minus is different from the subtraction operator, as subtraction requires two operands. So these are two different operators. One is the unary minus and one is the binary minus. So over here from an example it will be more clear. There is an implementation of the unary minus operator. So we have positive integer equals to 100, negative integer equals to minus positive integer. So it will basically convert 100 is positive, so it will convert it into negative. So we'll have the value minus 100, that will be set as negative integer's value. Then we are printing positive integer, so we'll get 100. Then we are printing negative integer, so we'll get minus 100. Alright, so now over here we'll get the new stuff, increment, from where we left in the previous class. So the increment operator, that is the plus plus increment operator, right? So it is used to increment the value of the variable by 1, right? So it is used to increment the value of the variable that you give by 1. So the increment can be done in two ways. One is a prefix increment, one is a postfix increment, and we also saw the differences between them in the previous class. Where prefix increment, what it does, it first increments the value of the variable and then returns the value. Postfix increment, what it does, it first returns the value of the variable and then it increments it. So we are going to see all of that in action also. So the prefix increment operator, first we are going to see. So in this method the operator precedes the operand, so it's like plus plus a, so the value of the operand will be altered before it is used. So basically they're saying it will change the value of the operand first and then it is going to be used. So when we say a equals to 1 and b equals to plus plus a, so first it will change the value of a, so then so it will set a value of a to 2, and then it will return that value to be saved in b. So b's value will be 2. Now postfix increment, in this method the operator follows the operand. So the operator that you have plus plus, that follows the operand, that is our variable. So the value operand will be altered after it is used. So like a equals to 1, when we say a plus plus, so first a's value will get returned, so b's value will be set to a's original value, that is 1, and then further after that, after setting the value of b to a's original value, so after setting b to 1, it will increment the value of a, so a will be set to 2. And then we have c equals to a. So now that after this statement a's value is 2, that's why when we say c equals to a, c's value in c will get 2. So over here here's the implementation. So when we say we have a equals to 5, b equals to 5, when we print plus plus a, it is going to increment the value and then print it. So we are going to get pre-incrementing a equals to 6, and then when we say post-incrementing b equals to, then we say b plus plus. So first it will return the value, so it is going to show 5 on the screen, but actually b's value will be 6. So pre-incrementing a equals to 6, we'll get 6, the value of plus plus a, and then post incrementing b, and then we getting the b plus plus values as 5, and after that, after getting 5, it is changing the value of b and setting it to 6. So now we are on the decrement operator. I hope all of this is clear. We have done it in the previous class also. So
Yes, clear.
all right. So next we have the decrement operator. So the decrement operator minus minus is used to decrement the value of the variable by 1. So the decrement can be done in two ways, like increment, that is prefix, and postfix. So in prefix, in this method, they are just completely the same, but in plus plus and it was just incrementing the value. In minus minus, it is just going to decrement the value. All the behavior is same, rest the behavior is same. So in this method, in prefix decrement, the operator precedes the operand. So we have minus minus before the operand. So the value of the operand will be altered before its use. So the value of the operand will be altered before it is used. So when we say a equals to 1, b equals to minus minus a, so it will first change the value of a. So a's value will be set to 0, and then we will set b's value to the new value of a, that is 0. So b will be set to be 0. Next we have postfix decrement. So in this method, the operator follows the operand. So we have a minus minus. So the value of the operand will be altered after it is used. So when we have a equals to 1, then we have b equals to a minus minus. So when we say a minus minus, it is first going to return the value of a. So b's value will be set to 1, and then a's value will be set to 0. And then when we say c equals to a, it will be set to 0. So we'll have a equals to 1 at first, then we'll have b equals to 1 and a equals to 0 over here, and then when we say c, its value is 0. So minus minus a will print 4, b minus minus will print 5. Alright, so next we have the not operator, that is also a unary operator. So the logical not operator, exclamation mark, is used to reverse the logical state of its operand. So if a condition is true, then the logical not operator will make it false. So for example, if x is true, then not x will be false, and if x is false, then not x will be true. So below is the implementation of the not operator. So we have a equals to 10, b equals to 5. Then when we say not a greater than b, a is 10, b is 5. So it is first going to check a greater than b. So 10 greater than 5, that is true, but then we have not. So it will reverse the result, and from true it will be false, right? And then when if over here in if we have false, it won't go inside the block, and it will go in the else block, and it will show a is greater than b. Alright, so very basic. We have also done this in the basic course also. So over here, one thing to note was that first it will evaluate a greater than b. If we didn't give the brackets, for example, a greater than b, we would have given this, right? So what would happen? Not a's value is 10. Now that's a truthy value, right? So when we convert true from not to false, so we'll get a falsy value. False value in integer is 0, right? So its integer representation is 0. So when we'll check 0 greater than 5, right, that will be false. So it will go in the else statement and will still print a is greater than b, right? But the behavior is different. Over here we have not a, right? And over here what we had this whole thing getting evaluated first, and then its result was reversed. Right now when we do this, first a's result is reversed, and then the condition is checked. Over there opposite was happening. First this condition was checked, and whatever the result we were getting, that result was reversed, right? So I hope this is also clear, the not operator, and also the difference between giving this in brackets and not giving it in brackets.
Yeah, it's clear.
Alright, so next we have the address of operator. So the address of operator and gives an address of a variable. It is used to return the memory address of a variable. So these addresses returned by the address of operator are known as pointers because they point to the variable in memory. So there are two uses of the AND operator. One is to create a reference variable, and other is to get the memory location of a variable. So now as we are using the AND operator as a unary operator, we are going to use it to take out the memory location of our variable, right? So if we and gives an address on a variable, so memory location is basically address. So if we have like int a, then we have integer pointer, right? So this will create a pointer variable, integer pointer variable. So over here what we can save as pointers value, it can be a memory location that contains an integer value. Next we are seeing pointer equals to and a, and is giving us the memory address of the a variable that is being set to pointers value, and pointers value is now containing a value that is an address pointing to a memory location where an integer is stored. So over here is the implementation. So we have int a, and when we say alright, so the code is wrong over here as the pointer variable is not created. So let's just create it ourselves. So we can say int star pointer, and then we can say point, or even better we can directly just assign the value. So we can say and a, right? So this will set the value of pointer to be the memory location of the a variable, and then we are just going to print that. Alright, so over here note this, over here the result over here we are getting is different from this, right? Why? Because memory locations keep on changing. When you create a variable, it will not always occupy the same memory location. If you are creating an a variable, once you run it, it may occupy some memory location, another time it may occupy some other memory location, right? So it won't always occupy one memory location. Whichever memory location it finds free, it will occupy that memory location. So you basically, we are just getting the memory location or the memory address of your variable using the AND operator. And pointers we have seen in the basic course also, we are going to see them in detail in this advanced course also. So next we have the size of operator. So this operator returns the size of its operand in bytes. So if we say size of integer, then it is going to tell us how many bytes our integer occupies. Like size of integer will give us 4 because integer occupies 4 bytes. So size of operator always precedes its operand. So it will always precede its operand. So operand is an expression or it may be a cast. So it is an expression or it may be a cast, meaning you can either say int, float in it, or you can give a variable whose size it will tell. So size of can tell two things: either the size of a variable, how much memory location a variable is occupying, or it can tell how much memory location a certain type of data type will occupy. So the size of operator in C++ is machine dependent. So for example, the size of an int in C++ may be 4 bytes in a 32-bit machine, but it may be 8 bytes in a 64-bit machines. So we have two types of machines, 32-bit machine and 64-bit machine. So int either may be in C++ it may be 4 bytes in a 32-bit machine. So when we say size of int in C++, on a 32-bit machine it may give 4 bytes, and on a 64-bit machine it may give us 8 bytes, right? So the size of result will always keep on changing, right, up according to your machine. So below is the implementation of a size of operator. So over here we have size of double we are taking out. So size of double will give us like 8, and size of int, what it will give us, it will give us 4. Alright, so over here we are getting size of double 8 and size of integer to be 4. So this was the unary operators chapter. Now we can move on to the bitwise operators chapter. Alright, so we have already seen bitwise operators in brief in our C++ basics course, and now we are going to see them in detail. So in C or C++, the following 6 operators are bitwise operators. So over here 6 operators will be given. Those are bitwise operator, also known as bit operators, as they work at the bit level. So you can call bitwise operators as bit operators also. That will be the same thing. They are used to perform bitwise operations in C++. So over here we have this operators in C++ chart. So we have plus plus minus minus unary operator. These are arithmetic, these are relational, these are logical, these are bitwise, right? So and or left shift, right shift, XOR and ones complement. So it's called ones complement, bitwise not, right? It's bitwise not, sorry about that. This is bitwise not and this is the XOR. Alright, so over here let's just look at this. The and, bitwise and in C or C++ takes two numbers as operands. So it takes two numbers as operands and does and on every bit of two numbers. So and basically what it does, it checks if two continuous or like corresponding bits are 0, both of them are 0, then the result will have at that place 0. If one of the bits is 1 and the other is 0, so then also the result, that digit on that place will be 0, that bit on that place will be 0. And if both of them are 1, right, then only we are going to get 1 in on that place. So we are going to look at all of these in detail. We have or next. So in C++ it takes two numbers as operands and does or on every bit of two numbers. The result of or is 1 if any of the two bits is 1. So if we have 0 0, then only we are going to get 0. If we have 1 1, 0 1 or 1 0, we are going to get 1. So in and is 1 only if both the bits are 1. In and we'll get 1 if only both the bits are 1. So if we have 0 0, 0 1, 1 0, then that will give us 0. And if only we have 1 1, that will give us 1. Then we have bitwise XOR. So it takes two numbers as operands and does XOR on every bit of two numbers. So the result of XOR is 1 if two bits are different. So if we have 0 1 or 1 0, then we'll get 1. But if we have 1 1 or 0 0, that will give us 0. So if we have two like bits like 0 0 and 1 1, that will give us 0. But if we have two unlike bits like 0 1 and 1 0, that will give us 1. Next we have left shift. So it takes two numbers. The left shifts the bits of the first operand and the second operand decides the number of places to shift, right? So the first operand will be which number to shift and the second operand will be how many places to shift. Next we have the right shift. So in C++ it takes two numbers, right shifts the bits of the first operand and the second operand decides the number of places to shift. Both of them are the same thing, but left shift is shifting to the left, the bits to the left, and right shift is shifting the bits to the right. Then we have bitwise not, that in C++ takes one number and inverts all of the bits. So it inverts all of the bits. So if we have 0 at one place, then it will convert it to 1. If we have 1 at one place, it will convert it to 0. So this is the truth table of bitwise operators. So if we have 0 and 0 together, so and will give us 0, like your or will give us 0, and your this is XOR, that will give us 0 because 0 and 0 will give us 0. Then we have 0 and 1. So and will give us 0 because both of the bits have to be 1. Or will give us 1, right, as one of the bits is 1, and XOR will give us 1 as these are unlike bits. Then we have 1 0. So 1 0 will give us 0 in and as one of the bits is only 1 and one of the bits is 0, right? Or will give us 1 because one of the bits is 1, and XOR will give us 1 because these are unlike bits. Then when we have 1 1, and will give us 1, as both of the bits are 1. Alright, then or will give us 1, because as both of the bits are 1, plus if either of the bits was 1, then also one of the bits is 1, at least one of the bits is 1, so that's why or is also giving us 1. But XOR is giving us 0 in this case. Why is that? Because these are like bits, 1 and 1. So XOR will give, in like bits it will give us 0, in unlike bits it will give us 1. So here's an example of bitwise operators in C++. So we have IO stream using namespace standard. Then we have A equals to 5, B equals to 9. 5's representation. So we are just going to change this. We are going to work with 4 bits only. 0, 1, 0, 1. And 9 is 1, 0, 0, 1. Right? So when we say A equals to A, comma B equals to B, right? So first we are just showing the both A and B's values. Then when we say A and B, so then we are performing the bitwise AND operation. So over here 1 and 1 will give us 1, 0 and 0 will give us 0, 1 and 0 will give us 0, and 0 and 1 will give us 0. So we'll get, in the end we are going to get 0, 0, 0, 1. So we are getting 0, 0, 0, 1, as 1 and 1 is in the end, right? And then we have 0 and 0, 0 and 1, and 0 and 1, right? So in this case it is going to give us 0, 0, 0, 1. So 0, 0, 0, 1, what is it? It is 1. So 0, 0, 0, 1 is the binary representation of number 1. As we already saw the calculation, it's 1 into 2 raised to the power 0. 2 raised to the power 0 is 1, and 1 into 1 is your 1, right? So in the end, when we say A and B, we'll get 1. Very similar with the OR operator, but the result is very different. We have A or B. So first it will check 1, 1. So one of the bits is 1, so it will give us 1 at that place, right? Then we have 0, 0, so it will give us 0. Then we have 0, 1, so it will give us 1, because either bit has to be 1. And we have 1, 0, so that will also give us 1. So we have 1, 1, 0, 1, right? So when we say A or B, we'll get 1, 1, 0, 1, and that is the binary representation of 13. We can also calculate it as 2 raised to power 0 into 1, so that is 1, plus this is 2 raised to power 1, so that will give us 0 only. Like 0 into 2 raised to power 1 will give us 0 only. Then 1 into 2 raised to power 2, 2 raised to power 2 is 4, right? So 1 plus 4, 5, and 2 raised to power 3 is 8. So 1 plus 4 plus 8, so that is 13. So 8 plus 4, 12, and 12 plus 1, 13. So A or B is giving us 13. Next we have the XOR operation. So what we have over here, we have 1 and 1, so these are like bits, so it will give us 0. 0 and 0 like bits, so it will give us 0. Then we have unlike bits 0 and 1, so that is going to give us 1. And then we have 1 and 0, that is also giving us 1. So 1, 1, 0, 0 is the the binary representation of 12, right? So when we say A XOR B, right, with 5 and 9, we'll get 12. So over here we are getting 12. Next over here we have this. We have your tilde. This is the tilde sign that is used to reverse the bits. So it will convert 0 to 1 and 1 to 0. So over here we are using it on A. So A is 0, 1, 0, 1, right? So it will convert 1 to 0, 0 to 1, 1 to 0, and 0 to 1, right? So it is first going to convert your first. Now the new number will be 1, 0, 1, 0, right? So we have 1, 0, 1, 0, and before that there are so many zeros, so all of that will be 1, right? So now over here this the reverse of your A, so this reverse of 5 will give us -6, and this is a different calculation. for to get the opposite of a, we are getting -6. So that's a different calculation that we are going to see later. So I'm going to explain that in the next class, the different calculation, right? So right, for now we are getting -6 as the reverse of 5, right? That is just converting 1 to 0 and 0 to 1. Next we have the left shift operator. So we are saying B and we are shifting it by 1, right? So we are shifting B by 1. So we have 1 0 0 1, right? So that will be shifted. So from over here we'll have 3 zeros in the start, and in the end 1 0 will be added. So in 8-bit, the 8-bit representation of your the answer will now be in we are going to see that in an 8-bit representation, and that will be 0 0 0 1 0 0 1 0. So it is shifting it to the left, and the result we are getting is 18, right? So this is the binary representation of 18. And then we are shifting right shift. We are using right shift on B also. So this will, what it will do, it will remove 1 from the end. So it is going to remove 1 from the end, and it will add 0 at the start. So now what we have 0 0 0 0 0 1 0 0. Right? So that is the binary representation of 4, right? So all of these were binary operators that we have seen. Most of them we have seen in the previous basic course, right? The tilde sign was new for us, of which I'll give the explanation in the next class, right? So now we are going to see some interesting facts about bitwise operators. But if you have any doubt on in the bitwise operators, in the calculation or anything, please feel free to ask.
No, could you just send me the link of the site again after class?
Yeah, sure, I'll just send you the link.
Thanks a lot.
Thank you. So next we have interesting facts about bitwise operators. So the left shift and right shift operators should not be used for negative numbers. So this is an interesting fact that when using for negative numbers, left shift and right shift, this is going to give us an unexpected result. So if the second operand which decides the number of shifts is a negative number, so if we say the second operand that we were we had for the number of shifts, like we are saying that shift this one time over here in left shift, we are saying over here that shift this one space, right? So if we, instead of giving a positive number, if we gave a negative number, it results in undefined behavior in C++. For example, the results of both 1 left shift -1 and 1 right shift -1 is undefined. So both 1 left shift -1 and 1 right shift -1 is undefined behavior. Also, also if the number is shifted more than the size of the integer, the behavior is undefined. So for example, 1 left shift 33 is undefined if integers are stored using 32 bits. So if integers are stored in 32 bits, that is 4 bytes, and we shifted 33 times, so what will happen, this will lead to undefined behavior as it is exceeding the memory space of your integer, right? And that is not like accepted in C++, so that will also lead to undefined behavior. Another thing is, no shift operation is performed if the additive expression operand that decides no number, or another thing is number, alright, so is 0. See this for more details. So we are just going to go to this link to make this more clear, as the language was not clear. So this is alright, so over here what they are saying, the no shift operation. So there is a no shift operation is performed if the additive expression, so if the additive expression, that is operand that decides no of number of shifts, is 0. So there is also a no shift operation that we are going to see later, right? So there's also a no shift operation that we are going to see later. So we are going to see this in detail at that time. Right, sorry for the confusion, I forgot that this is also an operation that we are going to see later. So, interestingly, the bitwise OR of two numbers is just the sum of those two numbers if there is no carry involved. Otherwise, you just add their bitwise AND. So, let's say we have A equals to 5 and B equals to 2. Since there is no carry involved, their sum is just A or B. So now if we change A to 6, which is 110 in binary, their sum would change to A or B plus A and B, since there is carry involved. So over here we have something called carry involved, right? So if we have, like, for example, 5 1 0 1 and B is 2, that is 0 1 0, so there is no carry involved, right? So what do we mean over here when we say 5 or 2? What will happen? Let's think logically. We have 0 and 1, so we are saying 0 and 1, so that will give us 1. 1 and 0, so that will give us 1, and 0 and 1, so that will give us 1. So what will be, we'll get 1 1 1. So if we see 1 1 1, what we have, 2 raised to power 0, so 1 plus 1 plus 2 plus 4. So 1 plus 2 plus 4 is 4 plus 2 6. Okay, let's just do this over here. 2 raised to power 0, that is 1. 2 raised to power 1, that is 2. And 2 raised to power 2, that is 4. So 4 plus 2 plus 1, that is 7. So 5 plus 2 is also giving us 7. So where 5 plus 2 operation is happening using the bitwise OR operator. But carry involved means if we say A to 6, then we'll have 0 0. At some point we'll have 0 0. So in binary, in the binary number we'll have 0 also, right? So that if we have carry involved, so if we have like over here, when doing the OR operation, when we will have 0 in the result, so when we have 110, then it will be 110 or 010. So 00 will give us 0. So when we, this is called carry involved. So when we'll have carry involved, then what will happen, the sum will be A or B plus A and B. So A or B, what is that? That will be, A or B will be 0 0 1 1. So it will be 110 over here, 110 plus so 110, what is it? 110 is your 6. So 110 is 6 plus A and B. So 110 and 010. So 0 will get 0, 1 will give 1, and 1 will give 0. So 010, that is 2, right? So 6 plus 2, that will be 8, right? So then we are going to get the result. So when 6 plus 2 8, we are going to get from A or B plus A and B when there is a carry involved. And when we have 5 and 2, A and B, then we are just going to get the addition using the OR operator, right? And basically what is over here, if you can if you see this, if you use for every binary number, right, for every like for every operation on the bit level, if you use this, then also over here we'll get the same result. With 5 or 2, if you use 5 and 2 numbers also, if you use this operation, then what will happen? We have 5 or 2, so that will give us 5 or 2, we know that is giving us the result, that is 7, plus A and B, so 5 and B, so we'll get 0 1, that is 0, 1 0, that is 0, 0 1, that is 0, so that will still result to 0. So over here we have 7, that is the result, plus 0, so that will also give us 7, right? So this over here method that is used to take out the addition of two numbers at the bit level can be used to add basically two numbers using their binary representations. Next we have the bitwise XOR operator, that is most useful that is the most useful operator for a technical interview perspective. So it is used in many problems. A simple example could be: given a set of numbers where all elements occur an even number of times except one number, find the odd occurring number. So for example, if we are given a example that given a set of numbers, so you have a set of numbers where all the elements that are there occur an even number of times. So if we have a number 2, that will occur even number of times, so it will be 2 times or 4 times in the set, right? But there's only one number that is an odd number, that is occurring an odd number times. So if you have 3, or like if you have 4, that may be occurring at like instead of an even number of times, an odd number of times, like 1 time or 3 times, right? So to like instead of like using taking out complex solutions of this problem, what we can use the XOR operator. So let's see how. So over here, let's just see first. Okay, so over here they are using the XOR operator. So let's just see. So first we are going to see the main method, right? So over here we have an array which has 12, so that is even number of times. 14, 14, 14, 14, that is also an even number of times. But 90 is odd number of times, right? So 90 is the odd number of times, right? Next we are going to take out the size of this array, right? So we using the program we have to figure out that the number occurring odd number of times is 90. So how we are going to do that? We have first we're taking the size of the array, so the length of it. So size of array, that will give us the memory location occupied by the array divided by one of its element size, so that will give us the length of the array that we saw in the basic course also. Then when we say find odd array n, so this is going to give us the result, and we are passing it the array and we are also passing it its length. So we are saying result is equal to 0 comma I, right? So we are saying result is equals to 0, and then we are saying I. So we are defining a variable result, and we are also initializing a variable I over here. Then what we are doing, we are saying I equals to 0, I less than n. So we are looping n number of times, right? So whatever is the length of the array, we are looping that number of times, right? And what we are saying over here, we are just saying result, and then we are saying XOR equals to array I. So a result is 0, right? And XOR equals to what this is going to do, array I. Array I will give us the current element in the loop on which it is, right? So first it will be on 12. So when we are saying 0 XOR equals to 12, so what this is going to do, it is first what it will convert, it will say 0 0 and 1 1, it will give 0. So in the start we'll let's just take the 4-bit representation. So over here we have result 0 0 0 0, right? And then we say or equals to array I. So we have 12. So 12, I believe 12 we saw over here, 12 was 12's decimal representation was 1100. All right. So when we say XOR 1100, then what will happen? Then 0 0 will give 0, 0 0 will give 0, 1 0 will give 1, 1 0 will give 1, right? So this will set the value of result to be 12, right? So as it will we'll get this result only, so that will be set to 12. Next time when 12 comes, right, then what will happen, we'll have 1100 already, and then we are going to do 1100 again. So 0 0 will give us 0, 0 0 will give us 0, 1 1 will give us 0, and 1 1 will over here also give us 0. So it will again reset the value of result to be 0 0 0 0, right? And we are right now the meeting is about to end, the class is about to end, so we are going to look at this. This is a very interesting example, so we are going to look at this example once again in the next class, and we are going to go more into deeper into this example, and I'll also get back to you about the no shift operation. So
Okay.
so let's
Thank
just
you.
continue in the next class. Thank you.
Okay.